Hello, everyone. My name is Dylan Erzik, and today I'll be presenting my project, Predicting Hall of Fame Induction with Decision Trees using MLB Career Stats. National Baseball Hall of Fame is often considered the highest honor that a Major League Baseball player can achieve. Induction is not just about performance, but it symbolizes legacy, cultural impact, and perceived greatness. The voting process itself is managed by the Baseball Writers Association of America, and voters are often given considerable discretion while they often consider statistics. The decision can also be influenced by narrative, reputation, error bias, and even controversy surrounding a player's career. Because of that, some players with amazing stats never make it in, while others, due to their intangible factors such as media perception and fan appreciation, with lesser stats may make it in. So this project applies a decision tree to examine whether it's possible to predict Hall of Fame induction using career statistics alone, and it also aims to identify which stats carry the most predictive weight. So the key research question being asked for this project is, can decision trees accurately predict Hall of Fame induction based solely on a player's career statistics? And this question is important because it challenges how we currently view greatness in baseball. It asks whether statistical performance alone is enough to replicate the decisions made by Hall of Fame voters who may be influenced by less quantifiable factors such as leadership, personality, or postseason success. So, to address this question, several objectives were set. First, the project aims to evaluate decision tree classifiers for their ability to predict Hall of Fame induction. Second, the project seeks to identify the key statistics that influence Hall of Fame induction the most. Are traditional stats like home runs and batting average still the dominant factors, or do we see other indicators like walks, games played, or consistency over time coming into play? Third, it's essential to assess the model's performance using standard evaluation metrics such as accuracy, precision, recall, and F1 score. And these allow us to understand not just how often the model is correct, but how balanced and fair it is across both classes. Hall of Famers and non-inductees. Lastly, the project intends to provide a transparent and reproducible analytical framework, which is very crucial. The model, data, and results should be understandable and replicable so that others in the field can build upon it. Transparency is especially important in sports analytics, where fans, media, and even the players themselves will often want to see not just the outcome, but also the reasoning behind it. I'll start with article, the new Bill James Historical Baseball Abstract, and um, Bill James is considered the father of sabermetrics, the application of empirical and statistical analysis to baseball. James challenged the long-standing reliance on subjective scouting reports and traditional metrics like batting average and RBIs alone. Instead, he advocated for a data-first approach emphasizing context-aware metrics such as on-base percentage, situational performance, and his ideas not only influence how fans view the game, but they also revolutionize front office decisions. His work was the foundation for what would later become the Moneyball movement, where teams like the Oakland A's use data to compete with the rest of the league despite having limited budgets. Second key study comes from Terrell and Mazur. In their paper on predicting Hall of Fame induction using logistic regression, they shifted focus toward using statistical models to replicate voter behavior, and their findings showed that awards like MVPs, milestone statistics such as 3,000 hits or 500 home runs, and all-star selections were significant predictors of induction. What's notable is that their model outperformed human voters in terms of consistency, and this raises the very interesting question that if a model can make more consistent predictions than humans, should it play a role in the actual voting process? The data set came from Kaggle and specifically a curated CSV file titled 500 Hits by Krupa Dharamshi. And this data included career statistics of over 1,000 Major League Baseball players, all of whom who had at least 500 hits during their career. And this threshold is really important because it made sure to only include established baseball players. Some of the key columns included were games played, at-bats, hits, home runs, runs batted in, walks, and batting average. And another important column was the binary Hall of Fame flag, which was a one if the player was inducted into the Hall of Fame and zero if otherwise. So for model design and implementation, I had to clean and prepare the data. So first, I just removed some columns that wouldn't really help make the model any predictions. So like player names. Then I handled any missing values by filling them in with the median of each column, and this just helped to prevent outliers from skewing the results. And I also checked the balance between Hall of Famers and non-Hall of Famers. I then used a decision tree model from the SCI Kit Learn library, and I chose this model because it's simple, clear, and perfect for explaining how decisions are made, something that's very important with sports analytics. I split the data into 80% for training and 20% for testing so that the model learned from most of the players and then made predictions on the rest. I use default settings, including something called Gini impurity, which just means the model tries to make the cleanest possible splits between Hall of Famers and non-Hall of Famers. And the goal of this was just to see if, based on stats alone, the model could tell whether the player deserves to be in the Hall of Fame. So here's a picture of my tree diagram. Um, and here you can see that each box or node represents a different decision point based on a player's career statistics. The top node is the root, and it asks the most informative question based on what feature splits data best. In our case, the root node splits on batting average, which tells us that this feature carried the most weight in separating Hall of Famers from non-Hall of Famers, which makes sense since batting average has historically been a hallmark of a great player. If a player's batting average is above a certain threshold, let's say around 315, they're sent down one path. If it's lower, they're routed to another direction. As we move down the tree, we can kind of see splits on home runs, batting average, um, runs batted in, games played, and even some walks and strikeouts. And these splits reflect how combinations of stats influence the model's decision. For example, a player with a 310 average and over 350 home runs would likely end up in a branch that predicts Hall of Fame induction. One thing to note are the colors of the nodes. Dark green nodes represent a high confidence predictions for Hall of Famers. The orange nodes represent confident predictors for non-inductees. And lighter shades in between mean the model had less certainty, usually because the input features had more mixed signals. So Decision Tree identified a few key predictive features that strongly influence its classifications, and these include the batting average, home runs, and runs batted in, three of the most iconic baseball statistics. What makes the decision trees especially valuable is that they don't just weigh the variables, they form specific interpretable rules. For example, one of the most impactful rules was that players with a batting average above 315 and over 350 home runs were almost always classified as Hall of Famers, while players with batting average below 270 and fewer than 1,000 RBIs were usually classified as non-inductees. These rules kind of reflect the model's ability to mimic how voters tend to think, favoring consistent high-level performance across a player's career. Next, this table breaks down the results by class of Hall of Famers labeled as Class 1, and non-Hall of Famers labeled as Class 0, as well as the overall weighted average. Looking at precision scores, the model was 80% precise when predicting Hall of Famers. For non-Hall of Famers, precision was even higher at 84%. For recall, which measures how many actual members of each class were correctly identified, the model had 75% recall for Hall of Famers and 87% for non-inductees. The drop in recall for Hall of Famers suggests that the model was slightly conservative when assigning Hall of Fame status. The F1 score, which balances both precision and recall, came out to be about 0.77 for Hall of Famers and 0.85 for non-Hall of Famers, with a weighted average of 0.82. Okay, just to wrap everything up, this project showed that decision tree models can predict Hall of Fame induction with about 82% accuracy. One of the biggest strengths of using a decision tree is that it doesn't just make predictions, it shows exactly how those predictions are made, which is important when trying to understand what makes a player Hall of Fame worthy. In this model, the most important stats were batting average, home runs, and RBIs, which is pretty familiar to anyone that follows baseball. Looking ahead, there are a few ways to build on this work. We can include more advanced sabermetrics like WAR or OPS to get a deeper look at player value. And I think it would also be valuable to factor in non-statistical elements like MVP awards, leadership roles, or postseason success. And lastly, it's just worth exploring fairness in the voting process. Historical patterns show bias across eras and player demographics, which is something that data could help reveal. Here are my references. And that was my presentation.